there everybody, welcome back to my YouTube channel, and we are back again with another video on the Let's Grow More Data Science Internship Program. Today's task is on the stock market prediction and forecasting. And the stock market prediction has recently become a huge hype. Everyone, all beginners can start at any age. The only thing is you need to know those tricks and tips that you can in order to succeed in this particular field. Now, a successful prediction of the future prices could yield you better profit as well. Now, before we go into this, one thing is that the model that I'm using for this can't be applied in real life. This is just for our own use, just to understand how this particular model works, along with how stock market predictions work usually. So we'll be using the stacked Lstm models. Now, if we go into, let's understand a brief history about what the stacked Lstm or the particular model as such. Now, assume a situation where you watched a movie or you're watching a movie. Now, in that particular movie, you as a human or as a viewer, you can predict what might happen based on the past or the previous scene. So that is what happens in this particular machine learning aspect, because we need to predict what is happening tomorrow with the data that we have of today, or maybe the 10 days or 20 days data that we have. That is where LSTMs and all play a major role. But initially, this came into play when we used recurrent neural network. Now, if you can see here, recurrent neural network has an architecture like this, where your input data goes into a neural network and it goes in loops. That means that is processed in each step, and then you get an output. If you unravel this particular network, recurrent neural network, the overall recurrent neural network, you'll get this as initial data will go into the neural network. It will keep on running. It will give an output. Now this output is sent to the next neural for the next run. So you can add the next input data. So let's assume that this was yesterday's data and this is today's data. So today's data is added, but it has information about the past data, which is yesterday's data, and you get an output h1, which is dependent on both x0 and x1. So this keeps on going. But there is one problem with using recurrent neural networks. Suppose you have a situation, let's assume that initially you only have five neurons with five inputs. So x0, the information of x0 will be stored here for x1 to analyze and predict and give us h1. Similarly, this keeps on going for x4. Let's assume it ends at x4. Now, this x0 or x1, it can still be retrieved. Like your h3 is still dependent on x0 and x1. But what if you have a huge data set, or not a huge data set as such, you have a huge neural network. Now, x0 might not be able to be visible. Maybe a small fragment might be there, but you can't retrieve it fully when you're working with ht plus 1, uh, or let's say x when you have the input as x 1 lakh or x thousand. So this x0 might not be there. So that is where LSTMs comes in. That is long short-term memory models. Now, LSTMs are a special type of RNNs. But the difference between LSTM and the normal RNN is that in RNN, if you're looking at A, you have your neural network A. There you only have one activation function. But if you're working with LSTMs, you have three activation functions. As you can see here, you have one, you have two. This you can consider as one neural network. That means based on this, you have the past data that's passed down to here, and you have the final sigma function here. So because of these three, you can get better accuracy and better output as well. Now, what an LSTM is basically, like I said, it uses its past information, it stores it effectively. Now, effectively in the sense, this x0 can still be retrieved perfectly for ht plus 1 output, which was not possible for our RNN. Okay, so in this particular project, we will be using the stacked LSTM model. Now, stacked LSTM is simple. To understand the name, it's simple. LSTM, you know what an LSTM does by now. What stacked LSTM does is, you're just stacking one LSTM on top of another, and then you're predicting. So let's see how we can go about with this particular project, or how we can go about with this particular analysis. As always, we'll be importing our relevant dependencies like NumPy, Pandas, and Matplotlib. Next, we'll be loading our dataset, we have the NSE dataset, and this particular dataset has date. We have the opening price, the high price, the low price, the last price, the closing price, total trade quantity, and turnover. When we looked at the dimensionality, 2035 observations with 8 columns. Now, as you can see, we have a date column. Now, having a date column means it's a time series data. Now, one important thing about time series is that time series data is always dependent on its past information. So that is why we need to retrieve every single point from its past. So if we can process our data, one thing, this is my head, that means the top 5 rows, and this is my tail, the bottom 5 rows. As you can see, this is in a format of 2018 to 2010. Now that is not something that we need, like, or we can keep it like that and we can go ahead, but usually our data should start from a lower date and then reach the higher date so we can predict the future values based on our last observation. So here what I'm doing is I'll be in, first I'll see what is my data type. We'll just keep the date issue for there right now. We have a data type and we've got the date data type as object. Now that is not right. We have to convert it to date type. So here what I'm doing is I'm converting my date column into date time format. Next I'm sorting the value. So I need it from 2010 to 2018. So with this particular code and this code, what I've done is I've done that exact same thing. I've got from 2010 to 2018, as you can see here. So when I plot, I'll be using the closing price here. You can definitely use high price or opening price. It depends on what you want to analyze or how you want to play about with this. So here you can see that there is an upward trend, but after 2010 or by the time it's coming to 2018, it's coming as a decreasing trend. So that means maybe this particular company has been suffering a huge loss after, let's assume it to be 1800 or something like that. So we'll see how we can go about with this. Okay. First thing that we need to do is we need to apply feature scaling. So we give a range of 0 to 1. This, because as you can see, you had initially the values as 121, 117, 118, those values. So you'll just keep it between 0 to 1. And you can see here you have 0.16, 0.163, 162, 0.62, and it keeps on going like it's between 0 and 1. Next, we need to obtain the training and test data. Now, when you're dealing with time series data, we can't apply the normal train test play that we apply using the sklearn package. So here you have to apply a different method. So what I have done is I've taken the 70% of my training size. That means the total length of my closing price data, and I've multiplied the length with 70%. So 70% of that total length I've taken as my training size, and the remaining, which is the 30%, I've taken as the test size. And then I've given for 0 from the starting point to the training size, which is the 70%, and all the columns I've taken as my train data. The remaining I've taken as my test data. Now, what I've done here is this is just a code in which we can obtain the independent and dependent features, which is based on the time step. Now, what time step is, I'll just explain with this particular example. Now, this example was I've obtained from Krishna X YouTube video. Now, he's explained this code perfectly. What I've done is, let's assume you have 7 data as your training data and 5 as your test data. Now, let's assume I kept this time step of 3. So my first observation is 125, 130, and 142. With the help of these 3, F1, F2, F3, I'll be predicting my output. Now my output should be 152, which is my 4th value. Next, I'll go to the next 3, which is 130, 142, and 152. With the help of that, I'll be predicting my next output, that is 131. So this keeps on going. Even for the test dataset also we'll do the same thing. So here I've used a time step of 200. So every time after 200, all my features first 200 will be taken, then the 200 and first output value will be printed here. And I'll get my X train and Y train values will be filled by the 201st, or then the next 200, next 201st. So it keeps on going. Even the test dataset also I've got X test and Y test. Now what I'm going to do next is I'll be just understanding the shape. So we have 200 columns or 123 rows. One thousand. I'm so sorry. 1,223 rows with 200 columns, and our white train shape is just 1,223 observations. Next, we'll be creating a stacked LSTM model. So in order to create a stacked LSTM model, you have to make sure that your input size is of three-dimensional. So for three-dimensional, we have the observations, we have the time steps, and then we have the features. So observations is basically, as you can see, the total observations, 1,223. The time step is the time step that we have selected, 200 time steps. And the number of features, there is only one feature, which is your closing price. So you'll keep it as 1. Next, import the required, models. So model is obviously going to be sequential, and we will have the LSTM layer and the dense layer. LSTM layer will contribute the input layer and the hidden layers, whereas the dense layer is just for the output layer. Now, as you can see, we have 3 hidden layers, 1 input layer. The input layer will have the input shape. So only the input layer will have the input shape. The hidden layers need not have that. Then we have the final dense model, which gives us one. We have one neuron there, which gives us the value. Now we got a model summary, and we can see there are a total of 1,38,671 parameters, and we will be compiling them. We'll be using the mean square error loss function, and also we have the optimizer as Adam. You can also use stochastic gradient descent as well, but I prefer using Adam because Adam is much more common and much more effective. Next, we'll be fitting our data, and we can see we'll be having 100 epochs. So we can see that initially the loss was 0.01 for the training set, and for validation set it was 0.03. But when we come towards the end, we can see that the loss has reduced drastically along with the validation loss as well. Like you can see that it was 0.03, it became 0.003. Next, we'll be predicting our train and test. So we have the white train thread using the model.predict train, and then this step is very important after predicting. Now, your predicted value is based on your scaled features, but your client or you yourself will not understand what those scaled features mean. So that is the point where you have to apply the inverse transformation so that you get the values as from 0.6 you get 121 or 118. So this is the important step that you have to apply there. Next, we'll be obtaining the model results, and we can see that for the training dataset, we've got a mean square error of 136.4, and test dataset, we've got 223.6. Now, that's not pretty bad. Next, we will be visualizing our plot. So, as you can see, the red line denotes the original dataset. The blue is our prediction on the train dataset, and the purple is our prediction on the test dataset. And as you can see, the training dataset fits perfectly. So does the test dataset as well. You can see that it keeps on going. Now, if you've seen in your previous, the initial one, I'll just show you that. The first plot that we had, I believe it is somewhere down here, if I'm not wrong. Yes, you can see that there was a dip here. And this is what we are seeing down there when we make our prediction, after we predicted our values as well. Yes, you can see here the purple, it fits perfectly, even though there are a few, long values, magnitudes are pretty higher compared to the original one. But yeah, we can still manage with that. Now we're making a future prediction. We'll be predicting for the next 30 days how the company is going to perform. So based on this, you can check if it's worth investing in that particular company. So first I've obtained the length of the test data. I've got it as there are 611 observations. Now the shape is basically 410 observations with 200 time step and one feature, which is our closing price. Now my input data should have the previous 200 because our time step is 200. So what is 611 minus 200 is basically 411. So I'm taking the values from the 411th position to every six to the till the 611th position so that I can predict the 612th value answer. And I've got the input data set as this. Next, we'll be converting that and then using this particular code where I'm telling that if the date is less than 30, then what I can do is I can use the model.predict to get with the input data, I can predict what is the value going to be. And with that, we can see that after a few predictions and after arranging it properly, we can see that there's a dip. That means after maybe your 2000 18 up to that particular date, there is no point in investing in it because there's going to be a huge dip. So this is something that we can go into. But one thing that's another thing that you can observe is basically it's still above 180. So maybe there can be a slight chance that this might increase because we have had values that is 117 in 2010, as you can see from our previous, I mean, from the first when we imported in dot head. So this is one method that you can do it. But yeah, maybe there are other methods as well. So please do feel free to comment down below and do suggest, do make it as much suggestions as you want on how I can improve this particular code. Thank you guys.